Guys, welcome all to the analog lecture series. So far we understood how to analyze BJT circuits directly in DC without learning any concept. So we have been solved so many problems and we understood how to play with the circuits without learning any concept. Just by applying KVL, KCL, you will be able to solve all DC type of questions. Now from this lecture onwards, we are going to learn how to solve the problems when it is related to the AC signal. So we know BJT analysis can be classified into two types. Basically, our bipolar junction transistor is connected with the two supplies. One is DC supply, another one is AC supply. When you are analyzing the circuits in DC domain, suppose if you are requested to calculate the value of emitter current, emitter to collector voltage or base resistance, so these kind of parameters can be directly calculated in DC analysis. So when we are doing DC analysis, directly we will be shorting all AC sources and we are removing all capacitors, because in DC analysis capacitor will be always behaving as a open circuited one. So that is what we are usually doing when we are doing DC analysis. Okay sir, but when we are going to do AC analysis, in AC, whenever we are trying to calculate input impedance, output impedance, voltage gain, current gain, normally these are all the four parameters that we are standardly calculating in AC analysis. Of course, apart from that, we also requested to calculate the value of capacitance and frequencies in high frequency analysis. Anyway, we are going to solve problems only at a low frequency analysis, because 95% of the questions will be directly asked from the low frequency analysis only. Okay sir, that conclusion is over. In DC analysis, there is no work for AC circuits. Directly we can short circuit all AC voltages and remove all capacitor. But when we are trying to do AC analysis, sometimes we also requested to do DC analysis and then we have to do AC analysis. Are you understanding? Suppose if you are requested to calculate the voltage gain or you are requested to calculate the value of current gain. During that period, first you have to do DC analysis, then you have to do AC analysis, because some parameter values might not be known. Okay, so anyway, let us directly start learning the concepts through the problems. First 3 to 4 lectures you are requested to watch the lecture how the way I am solving the problems. After that you will be getting the grip with the concepts. Automatically you will get the idea how to crack the questions when we will be solving the questions which are related to AC analysis. Okay, so let us start the first question. If you observe the first question here, there are two transistors are given. Read the question first. So let me read the question. In figure, both the transistors are identical and the value of beta is very large. So whenever we are observing that value of beta is very large, it means it is indirectly saying that the value of base current is approximately equal to 0 ampere and the value of collector current is approximately equal to the value of emitter current. This is what we did even in DC analysis also. Take the same data once again, nothing will be changing, but as I already told you that whenever we are going to do AC analysis, sometimes we also do DC analysis in order to calculate some parameter and then we can enter into AC analysis. So here from this clue I have collected the data. After that let us continue. Base to emitter voltage drop is given. Okay, and then the value of kT by Q, it means that is nothing but thermal voltage of the transistor. The value of Vt is given as 25 millivolt. Under the small signal, what we are going to do is small signal low frequency analysis. So we are requested to calculate the value of low frequency voltage gain. Of course, I have also told you that we are going to do low frequency analysis only. So in low frequency analysis, we are going to calculate voltage gain, current gain, input impedance, output impedance. So let us slowly understand all those things. Now what is the question? We have to calculate the voltage gain. Immediately when the moment you are seeing this word voltage gain or current gain or overall input impedance or overall output impedance, you have to immediately decide that we are going to do AC analysis. Okay sir. So let us try to bring the answer. So now if you observe the diagram, the diagram is given as two transistors given. See, let me name them. Transistor 1 and transistor 2. Can you please identify what type of transistor is given? What type of means whether it is NPN transistor or PNP transistor. Now first thing is we can easily identify the type of the configuration by observing the direction of the current. If the current is going outside from the transistor, then that is called NPN transistor. Yes or no? Yes. If you observe, both transistors are delivering the current. See there, the current is going outward from the transistor. So both are NPN transistor. And we know current direction always marked across the emitter terminal. So this is the emitter terminal. Obviously opposite is going to be collector terminal and another one terminal. This is base terminal. Now let me tell you one more thing here. Whenever you are observing the transistor, suppose see there, this is the NPN transistor, and if you take the base, and the base is directly shorted with the collector terminal. So this is collector, this is base. Whenever you are observing that the collector and base are shorted together, in that sense, in that cases, always, so whenever base is shorted with the collector, always your transistor will be simply behaving as a diode. So you can replace this entire transistor by a single equivalent diode. Of course, diode will be replaced by equal resistor and a cut-in voltage. When we are doing AC analysis, it is very important to consider two parameters. One is your cut-in voltage, that is voltage drop 0.7 voltage. But when you are doing DC, you have to consider this voltage. When you are doing AC analysis, you have to consider this resistor. I am telling that this diode can be replaced by, this is the equivalent representation of the diode. Diode means that is transistor only, but whenever base is shorted with the collector, then that is simply called diode. The behavior of the transistor is simply equal to diode, so I am replacing it by a diode. Now diode can be replaced by its corresponding equivalent circuit. In the equivalent circuit, we will be observing two parameters. One is RE, another one is cut-in voltage 0.7. So if you are doing DC analysis, then don't consider RE, only consider cut-in voltage. When we are doing AC analysis, in AC automatically DC supply will be short circuited. We will be considering the value of RE alone. Okay sir. Next, how can we calculate the value of RE? This is dynamic emitter resistance. This value can be calculated with the help of Vt upon emitter current or collector current. Approximately both are equal only. Either you can consider emitter current or collector current. Do you observe in your question the value of Vt is given? See, the clue is Vt, that is temperature voltage, that can be calculated with the help of Kt by Q. So if whenever they are defining that Kt by Q, it means that will be equal to thermal voltage only, that is already given in your question, that is 25 millivolt. It is always fixed. Very rare, sometimes in your examination they will give you 26 millivolt. By default, though it is not given, so in this question it is given as 25 millivolt. Suppose though it is not given, you can directly take this voltage as 25 millivolt. Okay. After that, in order to know the value of RE, I told you when we are going to do the AC analysis, then this transistor will going to be replaced by diode. Diode will going to be replaced by its corresponding equivalent circuit. But while doing AC analysis, it is very important to know the value of RE. Yes or no? Yes sir. How will you calculate the value of RE? If you want to know the value of RE, then we must know the value of Vt and the emitter current. Now, do you know the value of emitter current? No. I told you whenever we are trying to calculate the value of emitter current, collector to emitter voltage or some base resistor, these kind of calculations will be done only in DC analysis. So that's why I told you whenever you are solving the problems in AC analysis, sometimes there may be a need of DC analysis also. Here I told you we are going to consider this RE while doing AC analysis, but to calculate the value of RE, I need DC current. So that's why first we are going to do DC analysis and we have to estimate the value of emitter current. Then we will be transforming our circuit to AC analysis. Okay. So let us start with the DC and then we will try to explore the value of RE. Okay. So first we are going to do DC analysis. So take this circuit. First we are going to do DC analysis. So in this DC analysis, I am just requesting you all know how to do DC analysis because we have been solved so many problems in DC analysis. Take this circuit, try to calculate the value of emitter current, that is emitter current or collector current, because they told that the value of beta is very large. If the value of beta is very large, then base current will be 0. Automatically collector current and emitter current both are going to be equal. So by keeping all the given data, do DC analysis first. I am repeating, do DC analysis. While doing DC analysis, short circuit the voltage source, that is AC voltage source will get short circuited. Consider only all other DC parameter, calculate the value of emitter current. Now I am leaving it as a homework question. because I have delivered sufficient condition what to do in this case. So first try to calculate the value of emitter current and then estimate the value of Re. Once you find the answer, don't forget to drop your answer in the comment section. So remaining things we will be continuing in the next lecture. This is all for this lecture. Remaining things we will see in the next class. Thank you all.